Zoom recording. Okay. What questions can I help you with?
I don't have any questions right now.
Okay. Rebecca?
I think more examples would be helpful for me. I think I struggle with coming up with all of the isomers and I usually miss a few.
Okay, well, if you're having trouble with isomers, then let's just practice drawing isomers of alkanes. Okay, and then we'll do isomers of cycloalkanes. And we'll keep going from there. So I'm going to do a new share. Oh, I didn't turn my camera on apparently. No, it's on. So what's going on here? Okay, there it is. Okay, so we're going to practice drawing and naming isomers. Okay. And so we're going to start with some simple ones. So when we talk about the formula CH4, there's only one, and it's CH4. And when we talk about C2H6, there's only one. And I might as well draw this guy out. It looks like this. And here, there's only one. It looks like this. Now for C3H8, there's only one, and it looks like this. So you can see that when you're drawing these isomers, it takes a lot of time if you're drawing out all of the atoms and all of the bonds. Now this one we can actually draw this way, and these represent the same thing, and you can see how much quicker that is. When we get to C4H10, there's actually a couple of isomers. So when I'm trying to draw isomers, I always go for the one that has the longest string of carbons, one right after another. So here, 1, 2, 3, 4 carbons. And since I don't have double bonds or any ring here, I know that I've got 10 hydrogens here. And I see 3 on the end, 2 here, 2 here, and 3 on the end here. And when I say I see, I understand that this carbon has 4 bonds and the other 3 are 2, 3 hydrogens. I understand that this carbon has 4 bonds. I see 2 of them. So the other 2 bonds are to hydrogens. So that's one C4H10. To get the next isomer, I make the string only 3 long, and the other carbon has to be a substituent on this. Now, if I put that carbon on this end, these are the same thing. So I can't put it on the end. I have to put it on a carbon somewhere in the middle. And so this makes the most sense, of course. If you count all the carbons here, you'll see 4. 1, 2, 3, 4. If you count hydrogens on the tips, there's 3 each. And if you count hydrogens on the middle, there's 1. So we have 10 hydrogens. Okay, now when we name these, this one would be called butene. This one would be called methyl butene, or excuse me, methyl propene, butane, not butene. And this will be methyl propane. So when you name these, you name the longest chain first. That's the parent name. And then you name the substituent. You also tell people where the substituent is. In this case, we don't say 2-methylpropane, although it is on carbon 2, because it can only be on carbon 2. Okay, so we're about to turn things up a notch. We're still going to work with alkanes, so we're going to do C5H12. So if I want to draw the easiest isomer, I'm going to draw 5 carbons in a row. And this would be called pentane. Now to get to the isomers, what I'm going to do is I'm going to draw 4 carbons in a row. And I'm going to put one more carbon onto this somewhere. And it's going to be right there. And this is going to be called methyl butane. It's butane because the parent chain is 4 carbons. And this methyl group here is on carbon 2, presumably, but it can only be on carbon 2. It can't be on carbon 3. So we don't need a number there. Now, are there any others of these we can draw? And you might think, well, yeah, we could put this here, but these are both methyl butane. And technically the methyl is on carbon 2 in both of those. Now there is the possibility that we could make a parent of 3, making this a propane. So where are we going to put 2 carbons? Well, let me show you what we're not going to do. We're not going to do that because it turns out that this is also methyl butane. 1, 2, 3, 4 carbons. That's the parent. So the parent does not go from left to right or right to left. The parent is simply the longest chain, however it may be laid out the way it's drawn. So here I put the 2 carbons together to get my 5 carbons total, but I could have done this. And this is called we don't need the numbers. It's simply called dimethyl propane. So I'm going to cross that out. So these are all the isomers of C5H12. I know I'm going a little bit fast, but I'm going to have you work on these. So now we're going to do C6H14. So what I'm going to ask you to do right now is draw at least one isomer and name it. When you're done, give me a little thumbs up or something.
I think I have one.
You got one, Rebecca?
Yeah, I said 2-methyl pentane.
Okay, so how about you, Issa, do you have any?
Not really.
Okay, well, it's got to be 6 carbons long.
I'm still learning it.
It's got to be 6 carbons long. So
I know how to draw it, but not really. I haven't memorized the naming.
1, 2, 3, 4, 5, 6. That's the one I would start with.
That's what I had.
Called hexane. Now it sounds to me like, Rebecca, you decided you'd go ahead and start with 5 carbons and put a methyl there, and you called it 2-methyl pentane. Is that right?
Uh-huh.
And that's correct. Now, all of a sudden, we're using numbers. And that's because there's another one that's like this, and it looks like this. And it's called 3-methyl pentane.
Mm-hmm.
So how do we know these are different? And the answer is because the names are different. Now, what would happen if we did this? What would that be? Well, that would be 2-methyl pentane. Because we would number here 1, 2, 3, 4, 5. And this, which is a CH3, is called a methyl. So this is methane. When you attach it to something, you call it a methyl. Okay, so we can't put this methyl on the 4th carbon because it's really on the 2nd carbon. Okay, so we've run out of all the options for moving around this 1 carbon unit on these 5 carbons for the parent chain. So what's the next thing to do? And that is make the parent chain shorter. So now it's 4.
Oh, and we put 2 of the methyls on it then?
Yeah, and I would put 1 here and 1 here. And this would be 2,2 dimethyl butane. And you might wonder, well, how come we're adding numbers here, whereas here we didn't? And you'll see why in just a second. Now, if I put these 2 on this carbon here, it would also be 2,2 dimethylbutane. So that's not going to work. But if I put 1 here and 1 here, we would call this 2,3 dimethyl butane. So that's why we have to put numbers on these, is because these methyls might end up on different carbons, and that's important. Now, why don't I do this with one of these? Why don't I say, well, I'm going to take one of those methyls and put it right here? And the answer is that's no longer a butane, it's now a pentane. Okay, now why don't we do this? And if we're doing 4 carbons, why don't we take the 2 carbons that are left over and put them both together and call this a 2-ethyl butane, and actually an ethyl butane, because we wouldn't need a number. And the answer is because actually the parent chain is not 4. The parent chain is 1, 2, 3, 4, 5. So this is a 3-methyl pentane. So this is another example where I'm able to show you that we are not going from left to right. We are going to find the longest chain period. Okay. And I think I fooled you guys yesterday when I made some sort of thing where I did something like this, but I didn't do it with a line drawing. And I went like this and went like this, and you thought that was the parent chain, and it wasn't. The parent chain was actually this. Because here we've got 1, 2, 3, 4, 5, 6, 7. But if we start here, we get 1, 2, 3, 4, 5, 6, 7, 8, 9. That looks kind of like a crab, doesn't it? Okay. So I think these are all the ones with 4. So now we got to try 3 carbons in a row. Can we do this here? We have 3 carbons. Oops, I messed up. That's 4 carbons. Okay, that's 3. Is there a way for me to put 3 carbons on this? And I could try this, but what's wrong with that? How many bonds can a carbon atom have?
4.
How many bonds does that carbon have?
5.
So this does not work. So this is it for C6H14.
How do you know? Is there like a formula we can use to know if we have all of them? Or is it just trial and
No,
error?
there isn't. So you can see that as we move along, there's 1 for this guy, 1 for this guy, 1 for this guy, 2 for this guy, right?
Right.
And then when we get to 5, there's 1, 2, 3. Okay, great. And then here there's 1, 2, 3, 5. It goes up by 2. And then there's just no way of knowing. You just have to try them all. So let's try one together. Oh, not together. Let's try one where I'm just going to let you kind of go with it. Try and get all the isomers of C7H16 and name them.
I finally found the table for naming.
Yeah, you want to know all of the straight chain alkanes up to 10. So that's methane, ethane,
Mm-hmm.
propane, butane. After butane,
Okay.
they make sense. Pentane, hexane, heptane, octane, nonane, and decane.
Mm-hmm.
Okay, so when you think you're done, give me a little heads up and tell me you're done.
With all of them?
All of them.
Uh-oh.
You better have at least 2.
I have 3 right now.
So hopefully that's where you started. Always start with the longest because it's the easiest. And there's only going to be one that's the longest. So the next one's got to be 6.
Mm-hmm.
Where are you going to put that first carbon, that single carbon? On this one here? Nope. You'll put it there.
Mm-hmm.
And we're going to call that 2-methyl hexane because the parent is 6 carbons. You could move that carbon over to here, and what do you have?
3.
Methyl
Mhm.
hexane.
Now, if I move it over one more to there, what do I have?
3-methyl hexane again.
3-methyl hexane. I already have that.
Mm-hmm.
Yeah, so you're done with the hexanes.
So we're done with the hexane. So now what do we do?
The pentanes.
Pentanes.
And
And whenever I draw these, I always like to start with
the double
both
one.
of them, say on this first one like that.
Mhm.
2,2 dimethyl pentane.
Okay.
But then what I like to do is I like to keep one of them there and move the other one around. So what would that one be called?
2,3 dimethyl pentane.
That's right. So I'm going to keep that first one there on that carbon there, and I'm going to move it over here, the second one. Now what's this one called?
2,4
That's right.
pentane.
2,4 dimethyl pentane.
Okay, I missed that one. 'Cause
Okay,
I-
so my trick is to keep one on the first carbon you can put it on, which is the second carbon really, and move the other one around.
Mm-hmm.
Okay,
keep
so
numbering, even
so
when you have 2.
next I'm going to put one here. And I could put one here on the first one, but what would that be? 2, 3, right?
Yeah.
We already have that. So I'm going to put the second one there. Do we have that one?
No, that's 3,3.
3,3 dimethyl pentane. So I'm going to keep one of them on the third carbon and move the other one around. So I move it to here. Do we have that one?
Yeah, it's 2,3 dimethyl pentane.
Yeah, this is 2,3 dimethyl pentane. They're the same, so it's not an additional one.
Mm-hmm.
Okay, so could I put both of them on this carbon here?
It would
Well,
be
let's try.
Methylpentane again.
That's 2,2-dimethylpentane. So
Hmm.
we've done all the fives, or have we? Turns out there's one more five. I don't have to put the carbons separately as two different lines. I can put the lines together like this. And it still works out the same. This has the formula C7H16.
But it has an ethyl group now?
That's an ethyl. So this is called ethyl pentane.
And it doesn't matter which one you circle as being the ethyl. It could be the one on
No,
the right
you
or
could
the
call
bottom.
this the parent, 1, 2, 3, 4, 5. You could call this the parent, 1, 2, 3, 4, 5. You could call this the parent, 1, 2, 3, 4, 5.
Okay.
And regardless, the ethyl will be on carbon 3, correct?
Mm-hmm.
Because an ethyl cannot be on carbon 2 and it cannot be on carbon 4 in this case. It can only be on carbon 3. So normally we don't write a number down with this.
Can you explain that a little more to me?
Well, let's take a look here. This is a pentane, right? If I put the ethyl here, can I have 2-ethyl pentane?
Would you mind moving the
Oh,
So
the
can we have
hexane.
2-ethyl pentane here?
The hexane.
And the answer is no. This is 3-methyl hexane.
Mm-hmm.
So, well, let's try it here. Can we have 3-ethyl pentane? And the answer is sure, we can.
Yeah, okay. That makes sense.
Now here, can we have 4-ethyl pentane? And the answer is no, you can't. Because this is 3-methyl hexane.
Right, okay.
Okay, so you can see that as far as the pentanes go, there's only one place the ethyl can be. Where is that?
On carbon 3.
So why bother telling people? It's obvious, not to the novice, but to the experienced person. So when we teach you how to name these, we're not teaching you the novice approach. We're teaching you, well, if you were a pro, this is how it would be. It's kind of like, I was just thinking about rock climbing the other day. And it's kind of like the rating on climbs. The climbs are not rated from the perspective of a beginning climber. They're rated as from the perspective of a pro. So when the pro thinks about a 5.2 or a 5.3, they think, is there really such a thing? And when the beginning climber talks about a 5.2 or a 5.3, that's like climbing the third Flatiron in Boulder, Colorado, which, you know, is going to curl the hairs in your nose. So it's a big deal. So it's the same thing with naming these things. I'm showing you the professional way of naming them, and it can be a little scary for the beginner. I thought that was a great analogy.
So then when we get into alkenes and stuff, there's many more isomers because we have the Z and E ones.
Right. We're going to get there, but right now, guess what we need to do now that we've done the fives?
Oh no. We have to do the butanes now?
We have to do the fours. So here's a 4. Can I put an ethyl on this or a propyl? That is to say, can I do this? Because that's a propyl, right?
Can you move the
Oh, I'm sorry.
camera up or?
There we go.
Yeah.
Okay. So
No,
can you do that?
because the longest chain is 6. 1, 2, 3, 4, 5, 6.
Right.
Yeah.
So now this is not a butane. It is a 1, 2, 3. Boy, that 3-methyl hexane sure pops up a lot, doesn't it? Okay, so no, you can't put a 3 on there, but could we do this? Could we put 2 on there and a single and call it 2-ethyl 2-methyl? The answer is no, we can't. This is actually a 3, 3, dimethyl pentane. So now that you see the name, can you find the longest chain is 5?
Yeah.
Okay, so we can't put an ethyl on this guy. You can't put a propyl on this guy. Could we do this? 1, 2. So now we have 6 carbons, and the next one over here. So do we have 7 carbons? 1, 2, 3, 4, 5, 6, 7. We do have 7. Now, I guarantee as long as you don't put any rings in here or double bonds, you will have 16 hydrogens guaranteed. And we can actually count them. It's real easy on this one. Do you see these end carbons here? This one, this one, this one, this one, and this one. 5 end carbons.
Right.
They each have 3 hydrogens.
Mhm.
Okay. So what's 3 times 5?
15.
15. Where is the other hydrogen? Well, it's not there because that already has 4 bonds.
The third carbon.
Yeah, that's where the last hydrogen is to give us 16 total. So what's neat about the line drawing is you get the right number of hydrogens automatically. Okay, what would we name this guy?
I mean, would you do 2, 2, 3 trimethyl, 1, 2, 3, 4 butane?
2, 2, 3 trimethyl butane. Now, is there another way for us to put these 3 on this thing? And the answer is no. We cannot do this. Why can't we do that?
Over 4 bonds on the carbon.
Can we do this and get something different? Put the 2 over here and the 1 here.
It's the
We
same.
can, but it turns out it's this.
Mm.
This is carbon 1, this is carbon 2, this is carbon 3, and this is carbon 4. Okay, so we've done all the butanes. Is there any way for us to do a propane? So we have 3 carbons. How many more do we have to put on here?
4 more.
4. 1, 2, 3, 4. And the reason I have to do that is because if I don't do that, I don't get a propane. I get something longer.
Mm-hmm.
Can we do that?
No.
No, because that's an asterisk, right? Almost. Now it's an asterisk, right? So we can't do that. So that's all of the C7H16s.
Yeah,
What are those in total?
So now let's do this.
I missed
Guess how many there are. Now, I don't know how many there were here. Let's count them. 1,
9 of them.
1, 2, 3, 4, 5, 6, 7, 8, 9. This one didn't count. This one didn't count. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Mm.
If I'm counting them correctly. So 1, 2, 3, 4, 5, 6, 7. Oh, wait, we already had that one. 8 and 9. So yes, there's 9. Okay, now guess what happens if we do C8H18? There's going to be a ton of them.
Right.
Probably 12 or so, who knows? But what I want you to do is I want you to draw all isomers with the parent of hexane and also name them. So specifically, the parent of hexane. I can think of 3 right off the top of my head. 4. 5, 6, 7, 8. I can think of like 8 right now. Okay, since you have your mics on, I want to hear this when you're done. That means you're tapping out. We're going to make this like the mixed martial arts thing.
Just trying to name them, but I'm really not sure if I got them all.
How many do you have?
1, 2, 3, 4, 5, 6.
I have the feeling there's more than that.
For hexane?
Uh-huh.
So can you put like just methyls and ethyls on, or can you put the propyl too?
Well, if you put a propyl, how many carbons are in the propyl?
3.
And how many carbons in a hexane?
6.
So 6 and 3 would be 9. That's too many carbons.
Yeah, okay.
So for a hexane, no, you can't use a propyl.
That makes
Could
sense.
you use a propyl with a pentane? So how many carbons in a propyl?
Yeah.
3, right? And how many in a pentane? 5. 5 and 3 is 8. So yeah, you could use a propyl in a pentane.
For the C8H.
Yeah.
Yeah,
Keep
okay.
in mind, we're talking about C8H18. Not only could you use a propyl, you could use an isopropyl. I picked this one so that we would stay away from propyls. So you guys still working on them? I like the fire because that means you don't want to give up. That's good.
I think I've got like 5 so far.
Okay, I'm going to go at them. So this time I'm going to start with the ethyls. There's this one. And this one is called ethyl hexane. Now, why didn't I not tell you where it was?
Because it would have made the chain too long if it was on carbon 1.
I can't put it on carbon 1 or carbon 2. I can't put it on this carbon, which would be 1, or this carbon, which would be 2. I could put it here, but if I put it here, that would be carbon 3. And that would be 3-ethyl hexane. If I put it here, it's 3-ethyl hexane, so it doesn't matter. It's only ethyl hexane. Okay, so now I'm going to put 2 on there, and I'm going to do that here. And I'm going to keep 1 on the second carbon and move the other one around. So these are 4 different ones right away.
Oh,
This one's called 2,2-dimethyl hexane, 2,3-dimethyl hexane, 2,4-dimethyl hexane, and finally 2,5-dimethyl hexane. So I've got 1, 2, 3, 4, 5 right away.
mm-hmm.
Now, I'm going to get rid of these because we're going to make these all of these ethyls. And now I'm going to draw some more here. Now I like to move to here. And now where am I going to put the other one? Well, if I put the other one here, that's the same as this guy, right?
Yeah.
But I could put it here. And that's a 3,3-dimethyl hexane. Do I have another one of those?
No.
Okay, so I'm going to keep it there, keep one of them and move the other one around. Now that's going to be a 3,4-dimethyl hexane. Do I have a 3,4 anywhere up here?
No.
No. So now I'm going to keep it there again, and I'm going to move this over one more. What do we call this? 2,4-dimethyl hexane. Why is this 2,4 instead of 3,5?
Because you start counting carbons at the closest substituent.
Right. So that would be here. 2 and 4. And oh, we do have that one. So we got to cross this guy out. Okay. So the other thing that we could do is we could put them both on this peak here. What would that be? It'd also be a 3,3-dimethyl hexane. So it looks to me like we've done all of the fivers, or I mean sixers, and I thought that there would be like 8, but there's only 1, 2, 3, 4, 5, 6, 7. So we got 7, and we're done. Are you okay with that?
Yeah, I just keep forgetting to move when I put 2 methyls on 1 carbon, I keep forgetting to move it to all the other carbons. I missed the 2,5-dimethyl hexane.
Yeah, and actually I'm now thinking, let's go ahead and do the pentane ones here, because it turns out we can't really have a propyl. So let's do the pentane isomers. Okay, so how many carbons do we have to add to this parent of pentane?
3.
3.
Oh,
so I'm going to go ahead and put an ethyl right there.
Do you suggest starting with ethyls?
Yeah, I like to start with the ethyls and get them over with.
Okay.
Because they're actually kind of easy. So how many carbons do I have total here?
7.
7. So I need 1 more. So could I put a methyl there and have something?
Mm-hmm.
Okay, this one is called 3-ethyl. And normally you don't even need the 3, again, because it doesn't matter. 2-methyl pentane. So I'm going to get rid of this 3 because we don't need it. I'm going to put the ethyl in the same place because that's the only place it can go. Can I put a methyl there? Or do I have too many bonds to that carbon there? How many bonds to that central carbon?
4.
So we're okay. So what do we call this one? Ethyl 3-methyl pentane. Keeping the ethyl here, can I put a methyl there? And it turns out that this is ethyl 2-methyl pentane, because this would be carbon 1, 2, 3, 4, 5. Now, why did I not try to do a propyl? So here's a propyl, 1, 2, 3 carbons. Well, what is the name of that?
It's the same as,
It looks like a 3-ethyl pentane.
mhm.
So just an ethyl pentane.
It's an ethyl hexane. 1, 2,
Oh yeah.
3, 4, 5, 6.
Oh,
You get good at counting. Sometimes it's visually hard to see that extra, like, oh, I thought it was 5. For
Now
some
that's why
reason.
you want to make sure you draw it and then actually touch each carbon. 1, 2, 3, 4, 5, 6. And here I didn't touch each carbon. I just wrote a number next to it. So not only could I see that I counted it, so that I could actually say, I could see that I counted it because I wrote a number next to it. Whereas if you touch each one, you got to remember that you touched it.
Right. Is it okay if we draw it with like a little kind of extra dot in the center?
Yeah, I don't care. Okay, so do you see that this is not a pentane?
Mm-hmm.
So that's why I didn't do a propyl. Now we could do this though. Now, what would the name of this be?
Mm-hmm.
3 isopropyl.
Not bad, but it's not correct. It's ethyl 2-methyl pentane.
I just saw the thing that looks like a lower half of a stick figure.
Yeah, it looks like an isopropyl, that's for sure.
Hmm.
But you see here, if I number it this way, I still have a pentane. 1,
Yeah.
2, 3, 4, 5. I have a 2-methyl and a 3-ethyl. So it turns out one of the rules for chemistry is that more substituents is better than fewer. So that's why this is not isopropyl pentane. Because here, how many substituents do you have with this one? Only one, the isopropyl.
Mhm.
Here you have 2, a methyl and an ethyl. So to make sure that we don't run into this problem, the rule is more substituents is better.
Mm-hmm.
You still have to find the longest chain, but more substituents is better.
Hmm.
So we haven't finished the pentane ones, so let's go ahead and try and finish them up. Could I do that?
Yeah.
Yep. Could I do this? Move
Yes.
that guy over one.
Yeah.
Could I do this? Instead of putting 2 on the first one, could I put 2 on the middle and 1 on the first one?
Mm-hmm.
Now, what if I put 2 on this one instead of 2 here? That's something we already have, right?
Mm-hmm.
But could we do this? And the answer is absolutely. So what are the names of these? 2, 2, 3 trimethyl pentane, 2,2,4 trimethyl pentane, 2,3,3 trimethyl pentane. And then here we have a 2,3,4 trimethyl pentane. Okay, so you've gotten a lot of practice doing alkane isomers. Let's move on to other types of isomers. So let's look at alkene isomers. Now for an alkene, you have to have a carbon-carbon double bond. And the formula for alkenes is CnH2n. So when we look at C2H4, and remember, you have to have two carbons, so you can't have a C1, that's an alkene. This one is called ethene or ethene. The ene matches the alkene part.
Is that also the same formula for the cycloalkanes?
Yeah, but we'll worry about those later. We're going to focus just on the alkenes. Now, if we have a C3H6, so notice that's twice that. This is what we have, and it's called propene. Now for C4H8, there's this guy here. This guy is called 1-butene because there's also this guy. This guy is called trans-2-butene. And this guy is called cis-2-butene. So before we move on, let's talk about these two names, or these three names here.
Do you want?
Okay. So do you see the ene means there's a double bond?
Yeah.
The 1 means that the double bond starts at carbon 1 and of course goes to carbon 2. So there it is. This ene says there's a double bond. The 2 says it starts on carbon 2 and goes to carbon 3, 2 to 3. This one is also supposed to be butene, and it starts at carbon 2 and goes to carbon 3. Now, what does this cis and trans mean? When you have a double bond, if the hydrogens are on the same side of the double bond, we call it cis. And when I say same side, if we draw a line cutting the double bond into two, so one bond goes to one side and one bond goes to the other. If the hydrogens are on the same side, it's called cis. And if the hydrogens are on opposite sides, it's called trans. So I believe we talked about this last night, didn't we? And I was talking about the Transcontinental Railroad and all of that stuff.
We did, yeah.
Okay. So here we have these two. Now, we're not done with the 4s because it turns out these are all of the 4s we can come up with. But once we're done with the 4s, we go with the 3s. So what do we call that guy? Propene. Now we have to add another carbon to this. If we add it there, do we have that drawn anywhere before for the 4s?
No.
So this is called methyl propene. And this one you can't have a cis or trans because you don't have one hydrogen on this carbon and exactly one hydrogen on that one.
Right.
So these are all the fours. I think we'll only go up to the sixes. Let's go to the fives now. C5H, how many?
8.
10.
10, not 8.
It's double. Okay.
Mm-hmm.
All right. So what's the first one we come up with? Naturally, that guy. What do we call that? 1-pentene.
And that doesn't have cis and trans because it doesn't have the one hydrogen on each side.
Yeah, this has 2 hydrogens, so it won't work.
Right, okay.
Okay, now we can put the double bond here. And this does have a cis trans to it. Are the hydrogens on the same side or opposite sides?
It's trans.
They're on opposite. So this is trans what?
2
To
pentene.
or pentene, I'm sorry. So to draw the cis, since this side has less to it, I'm going to draw the other side just the way we drew the other one. And I'm going to draw this like that.
Mhm.
Can you see the 2 hydrogens come to the same side of the double bond?
Yeah.
Cis 2-pentene. Okay, so now we're going to draw this again. And what happens if I put the double bond here? What do we have now?
It's trans 2 pentene.
That's right. We already have this one. Because we're going to start numbering on this end so it's closer to the functional group. So we've already got this guy. So now what do? We make it one shorter. And so naturally, this is going to be a 1-butene. Where are we going to put the methyl? Well, let's put it here first. What do we call that?
2-methyl.
Yes. Why do we want to call it 2-methyl?
Because it's on the second carbon.
Well, remember with butane, we didn't bother telling people that the methyl was on the second carbon. But for this one, we do have to tell people that it's on the second carbon. And it's because of this. What would we call that? 3-methyl, 1-butene. Now, why do we start numbering here instead of on this side, which is closer to the substituent? And the answer is that when you're numbering, you do want the substituents as low as possible, but more important is to have the functional group as close to the beginning as possible. So functional group trumps substituent.
Okay, so if you have a double bond, always start closer to that with your counting.
That's right. So if we had drawn it this way, what would this be called? 2-methyl, 1-butene.
Okay.
So these are the same. Okay. So these are all of the 5 so far, right? Do any of these have cis trans? How about this guy?
No.
No, because there's 2 hydrogens there. How about this guy?
No.
No, because there's 2 hydrogens there. And since these are the same, this definitely doesn't have cis trans. So far we have 1, 2, 3, 4, 5. So we've done all the ones with 4. Let's try with 3. So here's 3.
I'm struggling to see the the difference between, or understand like the trans and the cis between the,
These two?
yeah, I guess I guess it's a little bit harder for me to see it in this particular type of arrangement.
Well, in that case, what you want to do is you want to put the hydrogens in. Do you see how I want to make each of those trigonal planar?
Uh-huh.
Does that look
Okay.
trigonal planar?
Yeah.
So that would be trans.
Mm-hmm.
And if I do it this way, do both of those look trigonal planar?
Mm,
Does that look like a 3 propeller? Right? Doesn't that look trigonal planar?
yeah.
And doesn't that look trigonal planar there?
Mm-hmm.
Okay, so these are on the same side, cis.
Mm-hmm. Mm-hmm.
So if you're having trouble seeing it here
Mm-hmm.
and here,
Mm-hmm.
you got to draw the hydrogens in.
Okay.
Okay. All right, how about the threes? Is there any way for us to do a 5 out of 3? I can't put it on the ends, can I? Because then it becomes a 4. And I have 2 more carbons to add, so this is where I'd have to put them. Is that okay? All of a sudden it went silent.
Oh, I'm on mute. I would say yes, because there's 3 carbons still, the longest chain.
I'd say no, because you got 5 bonds.
Ah. Okay.
Okay, so there's a lot of things you have to check off to make sure it's okay. Do the carbons, do you have enough carbons? Do you have the right number of hydrogens? And so forth and so on. Let's try one more of these. C6H what?
12.
12. So what's the one we're going to start with?
Just the regular hexane.
That one right there. 1 hexene.
Yeah.
Now we're going to move that double bond. And what do we have now?
2 hexene.
More. Trans.
Oh, trans 2 hexene. And now we need to come up with the cis one.
So let's draw the cis over here. So if I draw this, so it looks like a triangle, this would be the cis 2 hexene. Okay, how about that one? What's that one called?
Trans 3 hexene.
Trans 3 hexene. So let's start drawing from right here. So here, this goes up and then down. We want it to go down. And then it doesn't matter whether it goes to the left or the right. So I'm going to put it this way. This would be cis 3 hexene. And if we put the double bond here, then we've got another 2 hexene. So now that we've done all the sixers, what do we do?
The 5s.
The fivers. So what's this guy?
1 pentene.
2 methyl, 1 pentene.
I forgot the 2 methyl.
And then there's this guy. And then there's this guy. Luckily, none of these are cis trans because this carbon on the end has 2 hydrogens on it. And when you have 2 hydrogens on it like that, there's no cis, there's no trans. For cis trans, you need to have exactly 2 hydrogens, one to this carbon and one to this one, and something else here and here.
Right. So it has to either be on the second carbon or
Right.
the
2
third.
hydrogens exactly, one on each carbon of the double bond.
Mm-hmm.
Okay, so what's the name of this guy?
3-methyl-1-pentene.
That's right. What's the name of this guy?
4-methyl-1-pentene.
Right. And guess what? Now what do we have to do? We have to look at the 2 pentenes, don't we?
Yeah.
Oh my goodness, this is going to be a rough one. So there is a 2 pentene, right?
Yeah.
I could put a methyl there. Does this have cis trans?
No.
How many hydrogens bonded to that carbon?
4.
No.
Wait.
How many hydrogens bonded to that carbon?
Mm.
3?
Nope, none. 0.
Okay. The one that has the carbons bonded to it.
Yeah, so this carbon right here in the middle, kind of the middle, has 4 bonds. And you never show carbon-hydrogen bonds, so none of those bonds are to hydrogen. So how many hydrogens are bonded to this carbon? None, because we see 4 bonds.
Right.
This carbon here, how many bonds do we see?
3.
3. So how many hydrogens are bonded to it?
1.
1. So can this have cis trans if you only have 1 hydrogen here and none here?
No.
Can't have cis, can't have trans. So we don't need to worry about cis trans. So let's name it. We're going to call it 2-methyl 2-pentene. Okay, so now I'm going to move that methyl over to here. Can we have cis trans here?
No.
Nope. So this is going to be 3-methyl 2-pentene. Now this does actually have something like cis and trans. It's called E and Z, but our book doesn't really talk about E and Z. Our book would actually call this trans. Now I'm not going to go into why, but we're not going to mess with that. Okay, could I do this?
Yeah.
Can we have cis trans here? Think about it for a little bit. If you have to, redraw it and add the hydrogens in.
I think so, because they only have 3.
Yeah.
Yeah, it does matter. This is a cis or a trans.
Trans.
So the way to do it is redraw it so that you're not ruining your original drawing, right?
Yeah.
And put the hydrogens in and make these things look like triangles. So does that look like a triangle there?
Yeah.
Does this look like a triangle there?
Mm-hmm.
Perfect. Are the hydrogens on the same side or opposite sides when we go through the double bond?
Opposite.
So cis or trans?
Trans.
Trans. So don't be afraid to take the 10 seconds it takes to redraw it and put the hydrogens in.
So those are definitely trans then.
Yeah, this is definitely trans, and we call it trans 1, 2, 3, 4, 4-methyl 2-pentene. Okay, so now we have to draw the other one. So I'm going to draw this going straight up like that, and this would be cis. 4-methyl 2-pentene. So you're going to start getting used to, when you see this, you're going to go, oh, that's the cis. And when you see that, that's the trans. So I just want you to think about this for the moment. All of these notes that you're taking, and you're going to keep forever and store somewhere. In 1,000 years, when civilization has changed completely and your notes are found, they're going to be looking at this stuff going, what does this mean? And they're going to decipher it. This will be like Egyptian hieroglyphics. Won't that be cool? No comment, huh? Okay. So if I move the double bond over to here, can you see how that's just going to result in what we have here with the 2 pentenes? All right. So we're almost there. Let's do the 4s. I could have this. And I could have this. So what are we going to call these? This one's going to be 2,3 dimethyl 1 butene and 3,3 dimethyl 1 butene. Now that's not all of them. There's also this, and this would be 2,3 dimethyl 2 butene. And that's all of them. Was that enough?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh my goodness.
Well, it was really helpful just to go through them slower.
Okay. Do you guys want to go through the cycloalkenes once, a few of them or not?
That's up to you, Izzy.
I was gonna say, that's up to you, Rebecca.
If you leave it up to me, I'm just going to go for a walk.
I mean, it couldn't hurt.
Okay, let's do some cycloalkanes. We'll do the simplest ones first.
Tony's trying to help us, and we're like,
Cycloalkanes, just like alkenes, this is the simplest. So this is C3H6. Now C4H8. So do you see the name is just like a 4-carbon chain in that it's called butane, but because the carbons form kind of a circle, we call it cyclo.
Mm-hmm.
Now there's another one of these C4H8s and it looks like this. So what do we call that? Methyl cyclopropane.
And this is like another isomer.
That's right.
Okay.
And what carbon is that methyl on?
One,
It's either on carbon 1, 2, or 3. So what carbon is it on?
carbon 1.
Carbon 1. What if I drew it this way? What carbon is that methyl on?
Carbon 1.
Carbon 1. If I drew it this way, what methyl is that carbon on?
Carbon 1.
Carbon 1. So it doesn't matter how I draw it, that methyl is on carbon 1, period. So these are the two isomers of C4H8. Let's look at C5H10. So C5H10 is a house, the kind of house you used to draw in kindergarten when you had crayons. And if you're still using crayons, good for you. What do we call this one? Cyclo.
Pentane.
That's right. Now we can do one of these. What do we call that?
Methyl cyclobutane.
That's right. How you doing there, Issa?
This has been my favorite favorite one so far.
Okay. Now, can we do any other 4s? And the answer is no, but we can do a 3. We can do that. What would we call that? Actually, let me get rid of this one, because we've used 3 carbons, right?
Yeah.
We could do this. What would we call that?
Ethyl cyclopropane.
Mm-hmm.
That's correct. Excellent job. Now, we could also do this. What would we call that?
Dimethyl cyclopropane.
Mm-hmm.
Actually, we would call it 1,1.
Okay. So
And
one
you're gonna
one
see why.
dimethyl.
Pardon that? Pardon me?
1,1 dimethyl.
That's right.
So why do we put the ones there? Is it just because there's 2?
Well, what's that?
1, 2.
Mm.
1, 2.
Oh, that's right.
So we put the numbers there because they don't both have to be on carbon 1.
Okay.
Hmm.
Now, it turns out that there's actually 2 of these. So imagine I'm going to look at this guy from the edge, and I'm going to go ahead and move one of these here to here. So when I say look at it from the edge, let's pretend this is the triangle. This is kind of triangularly shaped. We're going to look at it like this. Okay? So when we look at it like this, I like to draw the edge like that. So can you see we're looking at it from the edge on?
Yeah.
Okay, so we can have both methyls like this, or we can have one methyl like this and one like this. These have different names. This one is called cis 1,2-dimethyl cyclopropane. Why do you think it's called cis? Well, we have hydrogens attached here, and they both go down, same side of the ring, not double bond. So here, since the hydrogens are opposite, this one would be trans 1,2-dimethyl cyclopropane. And so we have 1, 2, 3, 4, 5, 6 of the C5H10s. So those guys get tricky pretty quick, agreed?
Yeah.
And just to show you how tricky it gets without doing all of them, if we do the C6H12, this is where we start. And then we do the house with 1. Then we do the 4 with an ethyl and a 4 with 2 methyls. Okay. And here, this one has a cis and a trans. And this one has a cis and a trans. This one doesn't because they're both on the same carbon. And then when we go down to 3, we could have this. We could have this. We could have this. We could have that. And we could have that. And we could have that. So there's quite a few. And out of all of these, this can have a cis trans. And this one can have what's kind of like a cis trans also. Only this one's all messed up. I'm not even going to talk about it for the moment. But there's well, actually I will. There's like 3 of these. Now you're not going to be responsible for that, but just take a look. If you disregard all the cis trans, how many do we have here? $12, without regard for cis trans. What's the name of this one guy? Isopropyl cyclopropane.
And the other one next to it, to the left, is that just the propyl cyclopropane?
Propyl cyclopropane. This one here would be called 1-ethyl 2-methyl cyclopropane. And the reason the ethyl gets the number 1 is because E comes before M. And it always looks better if you're going to start with an ethyl that you put a 1 next to it instead of a 2. This one would be 1, 2, 3 trimethyl cyclopropane, and so forth and so on.
So will we be expected to know on that last slide with the, and this slide too, with the cyclopropanes, that they can have the cis and trans?
Yes, you should know that any cyclo with 2 substituents on it can have cis trans, as
Okay.
long as the substituents are not on the same carbon. So this, no cis trans. But this does have cis trans. So when you've got 2 substituents on different carbons, you got a cis trans.
And the best way you said to draw those isomers is from like the bottom of the triangle, kind of?
From the side.
Yeah.
Yep. Here's an example of a C6H12, not a C6H12, but this is a molecule. Can you see that this is cyclic, 6 carbons in a row?
Yeah.
Okay, so if I have a CH3 here and a CH3 here, does that look like cis or trans? It's trans. Now, if I draw the same thing, this here, and from here, I draw this like this. This is cis. So why are these cis and trans respectively? Well, trans, because you can see that they point in the opposite directions, right?
Okay.
And cis, because they point in the same directions. And honestly, it's really about the hydrogens, not the methyl groups. So here, you do have cis trans.
But we don't have like the nice double bond to draw our line through.
No, you don't. So with the rings, basically, if you look at the edge of the ring, if they both go in opposite directions, then it's trans.
Hmm.
And if they both go in the same direction, it's cis. And it doesn't matter if they both go up or both go down, it's cis. And I should draw these from the same carbon. I should draw them like that, opposite carbons. Okay?
Mm-hmm.
So if you look at a square on edge like this, so this is a cyclobutane. If you have this, what do you have? Cis or trans?
Trans.
Trans. And if you have this, what do you have?
Cis.
Cis.
And that would be the cis 1,2-methyl cyclobutane.
That's right. And this one would be the
Trans 1,2-methyl cyclobutane.
almost. Trans 1,2.
Methyl.
Nope.
Dimethyl.
That's right. Dimethyl cyclobutane.
Okay.
Okay. We've been at it for an hour and a half. You guys have been brutalized enough by me.
This chapter is exhausting.
That's why I wanted you guys to get started on it this week and not next.
And we'll be expected to know all the functional groups by the exam?
Yeah, functional groups are things I would put on my index card.
Right. But we're going to go over naming all the alcohols and esters and all the other stuff.
We'll go over what their names will be, but not how to name them. Some simple ones, yes, but other ones, no. For instance, if you were to name this guy here, this is an alcohol. It's called 1-butanol.
Okay.
Name this guy, it's called 2-butanol.
Okay. So
And-
like if it was 3, it would just be a propanol instead?
Yeah, if you had this, this is 1-propanol. This is 2-propanol. This is also called isopropyl alcohol.
And it's just the iso because the substituent's not on the terminal end?
Well, this looks like a 3-carbon unit, right?
Yeah.
And when it's a Y like that, or like this, it's an isopropyl.
Mm-hmm.
So here, the common name is isopropyl alcohol, but its real name, proper name, hoity-toity name is 2-propanol. This one is called ethanol, and we don't tell people where the alcohol is because it's either on this carbon or this carbon. This is carbon 1, this is carbon 1.
Mm-hmm.
You guys have probably heard of this one, and you probably heard of this one. Where do you find ethanol?
Gas.
I would actually say you find it more commonly in fermented grain and so forth,
Didn't
fruits.
the Obama administration add ethanol to our fuel though?
Yeah, it does, but I'm willing to bet that you're probably drinking more ethanol than you've used in your car.
Yeah. I know that in Indiana, they grow a lot of corn for ethanol.
Right. So the ethanol is used in fuel, but it's also used it's in alcohol. And where do you find isopropyl alcohol or 2-propanol?
Antiseptics?
Yes, antiseptics. Also, it's found in fingernail polish remover.
Wouldn't that be the acetone?
That's also fingernail polish remover too. You can find both. You can also find something called ethyl acetate. So there's lots of different products that you can use to remove finger polish. I would say out of all of them, isopropyl alcohol is probably the one you'd probably be least worried about causing a problem because you breathe it or something like that.
Mm.
But acetone on the other one evaporates a lot faster. And they work differently. They have different effectiveness.
I was
So,
about to say, I don't think I've ever tried using isopropyl alcohol to take nail polish off.
oh, you haven't?
No,
Well,
I normally use.
You can tell that I'm probably not the best person to ask about removing fingernail polish remover or fingernail polish, because I think I've used fingernail polish maybe half a dozen times in my life. And each time it was on a bicycle frame trying to cover up a little ding.
Oh yeah.
So I don't have a great amount of time using fingernail polish remover, or fingernail polish, I should say. I don't know if you guys have or not, and I really don't care. None of my business. All right.
You think acetone is a pretty like what is it, toxic substance then to breathe
No,
in?
it's not reactive really, but it evaporates very quickly, and the smell can really get to you.
Mhm.
So you never want to use acetone in a closed room that has poor ventilation. So like, using fingernail polish remover in the bathroom is really kind of a silly idea. It's too small. Unless you do what?
Open the window.
Open the window or turn on the bathroom fan. That would be better. It'd probably be better for you if you use your acetone in a large room where there's good ventilation. Outside would be best.
So the problem is breathing it, not necessarily applying it on your fingers and like it.
No, breathing it. It's the breathing of it. Because it evaporates so readily, it kind of can make you nauseous, and it's no good.
Good to know.
Very good to know.
It's not very reactive.
I think we could have guessed that though. It smells so bad.
Yeah. A lot of them are, they're all flammable. So you definitely don't want to be removing your fingernail polish and smoking a cigarette.
Right.
Okay. Don't do that. Or smoking anything else.
Or having just taken your nail polish off cooking.
Yeah. And no cooking over a stove, a hot propane stove.
While removing nail polish, and that's a lot of multitasking.
Yeah, that's a lot of multitasking. Smoking, removing nail polish, cooking.
It just sounds like a very busy woman, like someone with a lot of kids.
Like a Married with Children episode.
Yeah. Exactly. That's exactly what I was thinking.
That's actually kind of funny when you think about it. All right. Well, thank you for calling in, and we'll go over some more stuff tonight. Sorry I didn't get out that example lab report, but I'll be working on that tonight and trying to grade the exams.
All right. All right. Have a good evening. Take care.
All right. You guys have a good evening, and be safe.
Likewise.
One.
Bye.
Bye.
Bye-bye.